In one of the other videos, you probably remember me mentioning some limits that do not exist, as in if the limit does not approach a number, if the limit just kind of goes off into space, then the limit will not exist. So I've got a couple of examples for you behind me. So remember, DNE does not exist. So here we go. First one, I'm going to start over here on the side. I've got graphed y equals 1 over x squared. Now, as I approach 0, here's what happens. If I look at it from the left side, it kind of just shoots almost straight up. It gets really high really fast and doesn't really have a place of stopping. The same thing happens on the right side. So even though on both sides of 0, the left side and the right side, it's doing the same thing, it's not approaching a number. It's headed toward infinity. Now, in this case, we're going to come back to this one later, but for right now, we're going to leave it as does not exist. Now, moving on to the next one. The next one I have is y equals sine of 1 over x. Now, I could not draw this with any reasonable accuracy, so I actually went online and printed off a picture of this. Now, even a computer had trouble drawing this for one reason and one reason only. As we move towards 0, if I start out on the left side, it starts off as a nice, smooth curve. But what happens is, on the left side, it goes down, comes back up, and then it starts going up and down and up and down. But what happens is it's getting faster and faster and faster and faster as we get closer to 0. It just keeps increasing in speed. Same thing happens on the right side. If I start on the right side and I move towards 0, it starts off nice and smooth at first, but then it gets faster and faster and faster. So I'm going to use the word oscillate. This one oscillates. It goes back and forth and back and forth, and it doesn't do it at a regular speed. It doesn't do it normally. It moves quicker and quicker and quicker and quicker. It just keeps getting faster. And in that situation, we're going to say that as the limit as x goes to 0 of sine of 1 over x, that does not exist. Now, I'm going to give you one hint. If you are doing sine, cosine, tangent, any of those trigonometric functions, and you have a number over x, it's probably going to be one of these situations as x goes to 0, or as that denominator goes to 0. Now, I've got another one. This is a piecewise function. On the left part, we have a parabola. On the right part, we have a straight line. Now, if you notice what I'm looking at, the limit as x approaches 3. On the left side, as I follow the graph toward x equals 3, it goes to 1. As I start on the right side and I go toward 3, it goes to 5. Since these are not the same number, the limit does not exist. They don't go to the same place. That's an easy one. Now, on this first one, this is an easy function. Y equals the square root of x. Now, the question is, but Mr. Harold, if I plugged in 0, I would actually get a number here. And yeah, you would, but the problem is, this function, as you approach 0, is not defined for the negative numbers. If you plug in a square root of a negative number, you're not going to get an answer. It's going to be imaginary, not a real number. So in this case, because there is no left side, this limit does not exist. So, hope that helps.